joined the class. So sorry again.
Sure.
Okay, no problem. You can do thanks to uh, Anisha that.
Yes.
Assalamualaikum, sir. I'm
Yes.
also sorry for joining late.
Okay. Okay, no problem.
Thank you, sir.
Yes, we will start together this uh, course about correlation and correlation and regression. But in this opportunity, we will only study about correlation. Uh, okay, can you see my presentation?
Yes, Pak.
Yes, yes, sir.
Yes,
Okay.
sir.
Yes.
See it.
Okay. Correlation. The the keyword of correlation is relationship. So when we measure the correlation between two variables, it means that we want to get the relationship between the variables. For example, x1 and x2 or something like that. Okay. Once again, if we want to measure the correlation, so it's mean that we want to get we want to know uh, the relationship between variables. Okay. In regression term is the keyword of regression is influence. So if we want to regress some variables, it's mean that we want to we want to know the influence of one or more variable, one on or more independent variables to dependent variables. Okay, this is the difference between correlation and regression. So in regression, we want to know about the influence from one or more independent variables to one dependent variable. But in correlation, we want to know the relationship between two variables. In this opportunity, we will only study about uh, correlation. Okay. And in correlation, we can make a picture like that. If we want two variables, x1 and x2, and the uh, the relationship between two variables, x1 and x2, can be drawn like in my presentation. And we can see that there is an equality of two variables, equality from the two variables. Can be represented by the arrow, yeah, with two I mean two-way arrow, yeah, two-way arrow from x1 to x2. So it's meaning the equality from the two variables. If we want to count the correlation between x1 and x2, right? If we want to count the correlation between two variables, x is represents the a name of variables, And it's mean that we want to know the relationship among the variables. And then the measure of the relationship, namely correlation coefficient. Okay, correlation coefficient represent the measurement of a relationship between two variables, symbolized by R. And the value of R is between -1 until 1. Okay, from -1 until 1. Okay, the minimum value of R is -1 and the maximum value of R is 1. Okay, so the value of R is between -1 until 1. Okay, if the R is equal to 1, it means that -1 it means that the relationship is perfect when R is equal to -1. So when R uh, approach uh, when R is close to -1, it means that the two variables have strong relationship in negative directs. Okay, strong relationship. And then when the value of R is close to 1, it means that the two variables have strong relationship in the positive direct. And then when R is close to 0, so the two variables have weak relations. Okay, do you understand?
Yes.
Okay, yeah. So the value of correlation coefficient or R between -1 until 1. When the value is near to or close to -1 or close to 1, it means that they have a strong relation. And then when R is close to or near the 0, so the two variables have weak relations. Okay, and we can see from the picture that there are three pictures. We have two variables in variable. There are two. This is the pair of data and in the horizontal I mean horizontal axis, then in the horizontal axis and vertical axis. So this is the pair of horizontal and vertical axis. We can make a plot like this, yeah, the plot of the data, x comma y of x comma y, and then when the relation between two variables can be uh, depicted or can be drawn like this in the linear relationship, and then uh, and we can say that uh, there is a strong relationship in the left picture, left figure, left side, in the left side of figure, we can see that there is a strong relationship and positive and strong relationship between uh, the, the horizontal and vertical axis. And then the second figure, the middle figure, we can see that there is a strong and negative relationship between the two variables. Okay, and then and the last, the right side figure, we can see that there is no relationship or weak relationship between two variables because there are no trend in the relationship between two variables. Okay, so the correlation coefficient from the figure number 1, from the left side figure, is close to 1. Okay, close to 1 because there are strong and positive relationship between two variables. And then the value of correlation coefficient in the middle figure is close to -1 because there are strong and negative relationship between two variables. And then in the last figure, in the right side figure, we can conclude that or we can estimate that the correlation coefficient is close to 0. It's a very small correlation coefficient. Okay. I think it's the similar example from the figures. And then we can also classify the values of correlation in we have knew that the correlation coefficient is between -1 until 1, and we can classify the value in class like this. When the coefficient, when the correlation coefficient is between 0.9 until 1 in negative or in positive, we can make an interpretation that there is a very high positive or negative correlation. Very high correlation. And then when the value of the correlation is between 0.7 until 0.9, so that we can interpret that they have high positive or negative correlation. Okay, when the value is between 0.7 and 0.9, we can interpret that they have high positive correlation, and when the value is from minus 0.7 until minus 0.9, it means that they have a high negative correlation. And then the third is when the value of the correlation coefficient is between 0.5 until 0.7, we can interpret that the the relationship is moderate moderate correlation, moderate relationship. And then when the value is between 0.3 until 0.5, we can interpret that they have a low correlation, and then the remaining is negligible correlation. Okay, correlation between two variables. Uh, the correlation formula. This is the formula to calculate the correlation coefficient. I know that maybe you are not so happy with the formula because, but I'm sure that if we try to calculate, we try to try how to calculate this value, it will be no problem for you. And we will study together to calculate with the Excel, I think. I know, I'm sure that all of you have Excel, and so we can try together to calculate this. Okay, this is the formula R equal to sum of xi. Xi is values of the x variable in a sample. Values of example. And then x bar, you know x bar. X bar is the mean of the values of the x variables. The mean or the average. Average, you know, average, yeah. Average. So x sum of the xi minus the average of x. So the sample, the data minus the average of the data, and then multiply by the y minus average of y. Okay, this is the numerator, and then the denominator, and this is the denominator. You know the square root from the sum of x minus average of x square. And okay, I think it will be easier when we trying to calculate by using Excel. Okay. Okay, Excel on R or SPSS. There are so many software, uh, so many software that can be used to calculate the correlation. But SPSS is statistical program for social science, but it's not free for you. You have to pay a lot of money to yes to get the software. And then the R is free software, but it's not so easily for the beginner because this is language programming. You have you have to you have to write some comment. It's not simple. That is not simple. It's generally used by a statistician. Yeah, and specifically for statistician. Yeah, and then I think you have understand how to make Excel, so we can try together to use Excel, yeah, to count or to calculate the correlation. Okay. 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 This is the Excel. Oh, I'm sorry. I still open my Excel. Yeah. Okay. Okay. Can you see my Excel?
Yes, Pak.
Yes.
Okay. Uh, First, I want to know whether your menu in Excel, have you already opened your Excel in your computer?
Yes, sir.
Yes. Uh, please click your data menus, and is there a data analysis in the data menu, in the data menu like this? No?
I just found the analysis tools, sir, not data analysis.
Not data analysis. What?
Just analysis tools.
Analysis tools. Oh, I think maybe similar, yeah. Okay, maybe I will make an example and how to calculate the question, and then please after that one or two of you can share your screen, yeah, to show the Excel in your computer, yeah. Okay. For example, when we want to calculate the correlation between weight and height, maybe the sample is U. The sample is U. Uh, for example, I don't know, what is your weight? Maybe uh, 50, and maybe like this, yeah. uh, I don't know, maybe you rather fat, um, like this, and then mhm, mhm, okay, and then it's me, 72, and then okay. Okay, this is the weight in kilograms, and then um, height, height in centimeters. For example, like this, yeah. Then like this. Okay, this, this, and okay, it's only an example, yeah. Don't worry about it. Okay, it's only an example. Okay, we have 10 data from 10 persons, and we calculate the weight and the height. Okay, and after this we will also continue to calculate the correlation between two qualitative data in the next example, I think, about the correlation between performance and satisfaction. Okay. we can directly calculate directly by using data and then data analysis. Okay, I still don't know what's the main menu in your computer. Yeah, uh, correlation. Can you see the menus, data analysis menu in my computer?
Yes, yes.
Yes. The input ring, can you see? I will repeat my screen. Sorry. I share screen. Okay. I will repeat the okay. From the two variable, we can data analysis, correlation, and input ring. Person between number 1 and number until number 10, and then the input ring is between the two variables, and then the output string we will choose the place that we want to to place the value of the calculation. For example, in this, okay, just click OK. Nah, we can see the values. Okay. Can you see the values? The value. 0
Yes.
point 0 point.
0.8.
8.
Okay. 0.82. We can cut the decimal values until two two numbers. I think two numbers is enough. I think so. The correlation coefficient is equal to 0.82. Okay. When the value is equal to 0.82, we can say that from the classification of the correlation, uh, 0.82 is between 0.7 until 0.9. So we can say that the correlation or the relations between high and weak, yeah, weak and high is correlation is high. Okay, there is a high correlation between high and weak. Okay. Uh, I mean is hike, yeah. Sorry, yeah. Hike, hike, wake and hike or follow, I think. Yeah. So we can say that there is a high correlation between wake and hake. Okay. Okay. You understand? Please, you can copy the data from your Excel, or maybe you have already already done. Okay, if you have finished your work to copy the data, you can maybe we can take turns, I think. Did you to share your screen so I can see what's menu in your computer. Have you already finished to copy the data?
Yes, sir.
Okay, can I close my my sharing? Okay. Okay, I have stopped my share and okay, please, one of you, can you share your screen?
Yes, sir.
Please, Francisca. Okay. Yes. Can you click the data menu in your?
Okay.
Okay, analysis tools, data analysis. Okay, no problem.
I already.
Yes. Okay. Yes. Thank you very much, Francisca. I think good job from you.
Yes, you're welcome, sir. Thank you.
Okay. Another, you can stop your share. Okay. Once again, I think Sadaf, Stella, or Safas? None? Hello? Please. Okay. Please. One student again. Please share your screen. Stella or Sadaf, Sarfaras, none. Hand.
Hello, Paul. Can I share my screen even if I didn't copy all the data?
Okay. Please.
Okay, just. Okay. Here's my screen because I didn't copy all the data. I was trying to just random data.
Okay, maybe Okay, please close your screen and then I will open my screen once again so you can continue to copy the data.
Okay, but yeah, actually I can copy them later. But just we need to know that we have the function of data analysis right now, right?
And
The data should be the same.
no data analysis, yeah? Or
We don't have it.
yes, but I cannot see your menu to manage data model. Yes, no. Okay, maybe you can
Download a new version of
yes, Francisca, maybe
Excel.
you next you can help to hand to yes to improve or to
Upgrade my Microsoft Excel.
to
Okay, but
complete
I'll
the
try
data
my,
analysis menu. Okay,
Yes,
hand
sir.
yes.
yes, yes, but
You can ask for Francisca, yeah, to complete your menu.
okay, but
Okay,
thank you.
okay. Maybe another
Okay.
students. None. Sadaf, Sarfaras, Stella. Please. Or Nurul, Anisha.
Actually, I want to share mine, sir, but my Excel is the same with hand because I don't have a like, data analysis.
Oh, okay. Maybe Anisha.
Hello, sir. Mine as well, sir. My Excel's exactly same as hands
Okay.
as
Okay.
Excel.
Maybe after this course, Francisca can help for your friends uh, to install the data analysis, so that all of you can calculate the correlation from your Excel directly. Okay.
Yes, sir. I will try it. Thank you, sir.
Okay. There is a chat from Sarfaras. Oh, it also doesn't have a data analysis. Okay. I think Francisca will help you after our class. Yeah. I think directly after I finish my in my class. Okay, yeah, Francisca, yeah, you can directly continue to help to your friends.
Okay, sir.
Okay, yes. Okay, we have already finished to calculate the correlation coefficient, and then we can make a conclusion about the level of correlation coefficient between two variables, two measured variable, and then we will continue to measure the correlation coefficient uh, between two variables, two qualitative variables that can be measured directly from uh, yes, measuring instrument, I think, yeah, measuring instrument. Okay, I want to share my screen again. Screen. Okay. Okay. Can you see my screen?
Yes,
For
Pak.
example,
Yes, Pak.
okay. When we have two variables, for example, performance and satisfactions, and we want to know how the relationship between the two variables, uh, how uh, how the how the relationship between performance and satisfaction. So we want to it will be different from the first example. In the first example, we can calculate, we can count. I mean, we can count directly the variable, the weight and height directly. But in the two variables, the two qualitative variables, performance and satisfaction, we can count, we can measure directly the value of the variables. So as in our previous course, that we can measure the qualitative variable, for example, performance and satisfaction by using the indicators. For example, we when uh, we have three indicators for uh, performance variable, and then we have three variables for performance indicator, and we have four indicators for satisfaction variables. Okay. For example, we have 10 respondents, and then as in our previous experiment, we can uh, we have measured the value or the value of each indicator from each respondents. Okay, so for example, like this, it's just an example, and I only write the random number, and then the indicator of satisfaction, for example, like this is. I think it's the same with the performance. It's only an example, and with the a random number, I think, yeah. For example, like this, 3, and then 5, and then 3 again, and then 4, and then 2, and then 5, and then 1, and then 5 again, and then 4, and then 2. Indicator number 2 is simple 2, 4, 4, and 3, and 4, and then 5 maybe, and 2, 3, 3, 3. Okay. For example, an indicator number 3 is 2, 3, and 4, and 4, and 3, and 4, 2, and 5, and yes, just okay. And then indicator number 4 is 4, 4, 3, 4, 3, 4, 2, 4, 3, 1. Like something like this. Okay. Once again, it's just an example. Okay, yeah. So to represent the total value of the responder number 1 is we can make a summation between the indicators. So this is the, I think we can name the variable by P for performance, and then ICE for satisfaction. Okay, performance is equal to a sum from indicator 1, 2, and 3, like this. Okay. Okay, can you understand? Okay, turn, and then we just copy the value from the bus until the respondent number 10. Okay, so we can make it more, yes, beautiful. And then yes, I want to make it more, beautiful, more, not beautiful, yeah, more, yes, more, yeah, more neat, I think, neat. Okay, and then yes, okay, yes, yeah, okay, it will be more, yes, it's like this, and we'll, yes, okay, and we will use the same formula to calculate the sum of indicator number 1 until number 4, like this, and then we just copy like this, click OK, and yes, so we know we have to data like this, two data between P and S, performance and satisfaction, and then now we can calculate the correlation between performance and satisfaction. Okay, I think we will use the same formula like this, data analysis, then correlation. Okay, we input string is this, and then a control like this. Okay, so the correlation between P and S. Okay, and then the output string, where will we put the results of the analysis? For example, in this yeah, click OK. Oh, I'm sorry, I think yes, okay. Oh, must be a condition reference, I'm sorry. Okay, I want to, okay, we have to move the value, because in Excel formula, yes, the values should be in continuous, like this, yeah. PNS, we have to move the value like this, I think. Yeah. Okay. So now we can calculate the correlation between P and S. Okay, data analysis, correlation. Okay, okay, like this, and then the output rank, and this value is A15, no problem. And then click OK. Yes, we can see the correlation between uh, yes, okay, correlation between performance and satisfaction is equal to 0.67. Okay, 0.67, and we can say that the correlation between satisfaction and performance uh, is between 0 is equal to 0.67. It's in the range of 0.5 until 0.7. So the correlation, the relationship is a moderate correlation. Okay, can you understand? Do you understand?
Yes, yes, Paul. Yes.
Yes, yes.
Yes, sir.
Okay, so I want to you to continue your exercise, your first task at the previous course in that you have measure your own variables. I don't know, maybe effectiveness or something like that. And then I think you should measure two variables like this, and then you can calculate the value of correlation coefficient, and you can make an interpretation between you can make an interpretation your results. Okay.
Yes, Pak.
Okay.
Okay, sir.
Yes.
Yeah. I think you can after you improve your indicators, your questions, as I suggest a suggestion from me in the previous course, and then maybe you have to complete your variables. Maybe in the previous course you have made only one variables that be measured. So you have to complete or you have to add your variables. So you will have two variables that have measured, and then yeah, you can calculate the question, and maybe you will make a nice interpretation about your experiments. Okay. For example, when you decided in the previous course, you have to decided to measure the effectiveness uh, of learning language, and then And the second variable is maybe effectiveness and efficiency, maybe efficiency, and then you can measure, you can calculate the correlation between effectiveness and efficiency, something like that, I think. Okay. Okay, do you understand what
Yes, yes.
I mean?
Yes.
Okay. I think it will be your second task to complete your first task. Okay, and then maybe in the next course, maybe the last course, yeah, you have to present your tasks, all of you, yeah, it's one by one to present your task. Okay, and I think there are 1, 2, 3, 4, 5, 6, 7, 8 students. So when one student uh, presents your task in about 7 minutes, okay, 7 minutes to present, and then 3 minutes for question and answer. So one student needs about 10 minutes, and there are 8 students will need 80 minutes for presentation, and then 10 minutes for introduction from me and closing statement from me, I think. So we will finish our course in the next course for 90 minutes. I think it will be a nice time, yeah. Okay. um, okay. Okay. Do you understand, all of you?
Yes, Paul.
Okay.
Yes.
Okay, maybe I think enough from me in this course. I will, yes, I will leave from this meet of this, and but I hope that you, all of you, will continue. You still have a few times, and Francisca will help you all to complete your Excel, so all of you can use a data analysis to calculate the correlation. Okay.
Yes.
Okay. Before I leave from the meets, please, I want to make a picture with all of you. Can you open your camera for a few minutes, I think?
Can we make it next time because I don't put on my hijab?
Okay.
But can we just for next time, inshallah, be ready?
Okay.
Because it's kind of messy today.
Okay. Maybe okay. Sadaf. Yeah.
It's ready.
Wow. It's your house, your own house, your parents. Yeah. Okay. Are you still mute, I think?
Yeah, I'm sorry.
I forget.
My parents.
Sadaf, where I come from, Sadaf?
I'm from in Pakistan.
Oh, Pakistan. Okay. Yes. Nazrin, can you open your camera like Sadaf? Maybe accept hand. uh,
Maybe next time, inshallah.
okay, no problem. Yeah. Sarfaraz. Okay, thank you. Sarfaraz from Pakistan too, yeah?
Yeah, sir.
Yes. Okay. Okay. Another? No. Okay. None?